Hi everyone, today I'm here to give presentation on the topic sentiment analysis for movie reviews with my teammates Navya and Shrimana. These are the contents that we are going to in this presentation. First, introduction. Second, data extraction. Third, data analysis. Fourth, data modeling. Fifth, result. And at the end, conclusion. Sentiment analysis is a technique by which we analyze the emotion behind a text and categorize it into positive, negative, or neutral. Why is it really so important? How do we generally get to decide whether we have to watch a movie or not? By reading its reviews. Some reviews are very short and crisp, by which we get to know whether we have to watch a movie or not. But on the other hand, some reviews are very lengthy. Some even have spoilers in it. So here, sentiment analysis come into the picture. It will analyze that reviews and give us whether the movie is good or bad. Here we have taken 5 sentiment into consideration. First, strong positive, positive, neutral, negative, strong negative. Here we have not used any pre-existing data set. We have scraped the data on our own from a website called IMDb. We have scraped the data of 2 movies here, Oppenheimer and Barbie, and we have scraped this data using Beautiful Soup. Oppenheimer has 3,543 reviews. On the other hand, Barbie has 1,483 reviews. In our dataset, we have taken into consideration movie, title, movie review, and rating. The dataset we obtained after scraping the data is pretty much clean, but is heavily unbalanced. Now Navya will continue.
Hey everyone, this is Navya and I will be talking about data and sentiment analysis. Once we web scraped the data from the IMDb website for the movies Oppenheimer and Barbie, we stored the data into a data frame. Then we cleaned the data by removing any special characters that might be present in the data. In this process, we also removed full stop, comma, and apostrophes, and we also converted all the words to the lowercase. In the next step, we did the stemming and lemmatization. But what exactly is this and why is it even required? So some of the reviews can have words that basically mean the same. Like for example, organize, organizes, organizing. So the goal of both stemming and lemmatization is to reduce the inflection forms and sometimes derivationally related forms of a word to a common base form. So once we performed this, the data was now ready to be analyzed. So we went ahead with the sentiment analysis of the data. We used sentiment intensity analyzer for the same. So this model basically gives a sentiment score for the reviews. Now, based on the sentiment scores, we categorize the data into 5 categories: strong negative, negative, neutral, positive, and strong positive. So when we categorized the data, we found that the data was highly unbalanced. So then we went ahead with a random oversampler. Then we oversampled the data and we got the balanced data. Now we use this balanced data to train the naive Bayes model. So this is the recap of the sentiment analysis. We got the text input, then we performed tokenization, stop word filtering, negation handling, stemming, classification, and then sentiment categorization. Coming to data visualization. So in data visualization, this is the word cloud. Word cloud basically gives the most commonly used words in different sentiment categories. Here we have this for the sentiment neutral. For the movie Barbie, we have some words like good, woman, um, Barbie. And for the movie Oppenheimer, we have time, scene, etc. Then coming to the pie chart basically shows the distribution of the sentiment categories. We have taken the movie Oppenheimer here to show the visualization. We can see that 77.4% of the reviews were strong positive reviews, and then followed by 13.3%, which were strong negative reviews. Coming to the scatter plot. So this scatter plot shows the distribution of the review length when compared to the sentiment score. We can see that when the review length is small, the data is evenly distributed between we have equal distribution of sentiment score, but as the review length increases, the sentiment score also increases. Now, this is the box plot. In the box plot, we can see that it is highly evident that a strong positive has the most number of outliers in both the movie Oppenheimer and Barbie. Then this is the heat map. In the heat map basically shows the correlation between the different sentiment categories. So the darker shades means that there is a strong and positive correlation, whereas uh, light colors means that there is a weaker and negative correlation. Over to Shrimida for data modeling.
Moving on to the data modeling part of this project, we use 3 different models in our project. All these 3 are different variations of the naive-Bayes models. Bernoulli, multinomial, and Gaussian are the models that we used. Before moving on to discussing the results, I think it is important for us to understand why exactly we chose these specific models for a project. When we were doing some research on which model to use, we understood that naive Bayes is one of the most commonly used when it comes to text classification and text analysis problems. And we did not want to go into deep learning and natural language processing models because that is too complicated for us right now. So out of all the easily implemented machine learning models available, naive Bayes was giving the best results for text analysis problems. And our project is solely based very highly dependent on text analysis and classification. So we came to the conclusion that this was the best model to go ahead with. How exactly does this model work? So when there is a target variable and there are multiple independent variables that affect the target variable, what this model does is it is going to divide all these independent variables into different classes, and we are going to calculate probability of each independent class. And the class with the highest probability will be chosen to predict the target variables, values of the target variables, and based on that, we calculate the accuracy and everything. So this is just an overview of how the model works. I'm not going to go in depth over here because that might become irrelevant to the project. And we have been using Python language throughout the project. And for this particular model implementation, we have used the scikit-learn library. Moving on to the results, here we can see there are 2 different tables, for one for Barbie and one for Oppenheimer movie review data set. In the Barbie table, we can see that the accuracy is very comparable, surprisingly, for both Gaussian and multinomial models. But when it comes to precision recall and F1 score, Gaussian has performed slightly better than the multinomial model. When it comes to the Oppenheimer movie, we can see that multinomial model has performed way better than both Gaussian and Bernoulli with respect to accuracy, and as well as precision recall and F1 score. So overall, we can see that multinomial model is giving the best results, although Gaussian is following multinomial with good results right behind it. But yeah, this difference between the results can be because of the data imbalance. As we've seen before, there is a slight imbalance in the original data set between the strong positive and strong negative reviews that we got and the rest. There was a slight difference, which is very normal for any movie reviews. It's not compulsory for people to like, all of them to like or all of them to dislike the movie. So it is, I think that is very normal, and that is what has caused the differences and the differences, minute differences in the models. And to sum it all up, what exactly are we doing here and why is it important? So analyzing a movie review and giving it a simple score or simple 1 or 2 words, analyzing the whole review is very important because nobody these days has the time to sit through and read 70 to 100 words of a review that a person can write about a movie. They just want to understand whether the movie is good or not, and they just want to make a decision on whether to watch it or not. So doing sentiment analysis and just summing it all up into one small compact answer can really help the customers watch and make a decision about the movie, which will also help the movie's publicity as well. Future work. There can be some improvements that can be done to the existing work. We can use some advanced deep learning and natural language processing models in the future. There was one thing we observed, is if suppose there is a movie review which says it is terrible for anybody who did not watch the movie, which means it is a very good review. But since it had the word terrible in it, it is going to give it a negative score, and which will reduce the rating of the movie with respect to a project. So if we can use a different model, which is more complicated and can analyze the context of the review as well, instead of just analyzing the words in it, that will help in understanding the reviews better and giving the whole model a better result. And one more thing is, if we can take into account the upwards and downwards of a review. So this will help because not a lot of people are interested in writing a whole review. So if there is a negative review and a lot of people are downvoting the review, which means a lot of people don't agree with it. So if we can add some weightage to that negative review, because a lot of people think that that review is wrong, then that way we can reduce the bias towards one person, or if a specific person liking it or not liking it, reflecting on the review of the whole movie. That can help in giving a better result as well. So these can be some things that can be implemented in the future. These are some of the resources that we went through, if anybody is interested. And thank you. That would be it.